Right, hello everyone. So they always say you should start with the worst stuff first and then go to the good stuff. But I today want to start with the good stuff. And is there anybody that's learning Kotlin or wants to learn Kotlin and you'd like a really cool resource? Hands up. Anybody that's learning. So this gentleman is looking extremely happy. Kotlin in Action, second edition for my colleagues. I hope you enjoy the book. So yeah, that's. I hope you enjoy the book. My colleagues wrote it. It's now the second edition. That's how I learned Kotlin as well. And I'm now a developer advocate for Kotlin at JetBrains. So yeah, you're welcome. All right, so welcome to Kotlin Multiplatform Alchemy, making gold out of your Swift interop. So I'm going to start off with a gentle introduction to Kotlin Multiplatform. Who here has fiddled around with Kotlin Multiplatform? They've tried it, or it's brand new to you? Because I can adjust the talk. Who's played around with Kotlin Multiplatform? Played around. Okay, so we're going to start with a very gentle introduction, and we'll see how it goes. If you guys get lost, just start waving frantically, and I will stop talking, and we can sort of just go over the basics again. All right. So what is Kotlin Multiplatform? That's always a good place to start, right? So it's a technology by JetBrains that allows teams to share common code between platforms. Now, I want to sort of focus on these two terms, common code and platforms. So perhaps you're wondering, okay, which platforms can I share code between? So there's server, and the predominant one is Android and iOS. People always talk about KMM. That's actually incorrect, because you can also share Kotlin between desktop and server and web as well. So it's not just Kotlin Multiplatform Mobile, it's Kotlin Multiplatform. So it's KMP, right? So before Kotlin Multiplatform, when you developed an app, sometimes you had an iOS app, Android app, a desktop app. And they all sort of were developed in silos. So when you had your different apps, you would maybe architect them in a similar way. They would have a data layer where you interacted with the web services, or you had a cache, or you had a database. Then you had your business logic, you'd have your presentation logic, and then you'd have your UI logic on top of that. So with Kotlin Multiplatform, you could, for example, start with just sharing business logic. You could share your HTTP clients, you could share some business and domain logic. But you can also take it one step further. The choice is yours whether you want to or not. And you can start sharing presentation logic. Or with Compose Multiplatform, which is now a contender to Flutter, is you can start sharing your UI layer as well. And only really do platform-specific code on your platform and on your different platforms. So you're still able to do all the platform-specific stuff, like work with a file system, get your device's location, all those things, but you have to do those on platform-specific ways. So today, basically what I want to sum up here is that you can actually just share anything you want to share, and then have platform-specific code. You can do things in a platform-specific way that you want to do in a platform-specific way, or something that you're required to do in a platform-specific way. So you can share anything you want to share, and you can do sort of locally what you want to share. But today's talk, we're really going to sort of like, I just want to zoom in here. We're really going to focus just on iOS and how it's going to connect with this shared code. So iOS has, is obviously written in Swift, mostly written in Swift with SwiftUI or UIKit and Objective-C. And you want to connect those, this shared Kotlin code with this iOS code and use from iOS this Kotlin code. So we want to today really talk about this, how we connect the iOS and the shared Kotlin code with each other. Okay, so this is actually so what I want to talk about here is how these languages talk to each other. And this is called language interoperability, or interop. Okay. So I just want to go back here. So why would we want to go ahead and do something like this? So firstly, the flexibility to choose what is shared and what isn't shared. Okay, so you could choose to do business logic. You could share all your business logic across Android, iOS, desktop, server if you wanted to, or you could just share a small feature, or you could share almost everything. Okay, then next, you can choose what to share in a new, you can choose to share in a new or existing project. So you don't have to wait around for a greenfields project, a new project to come around. You can start using it in your projects now. And you can also have, because your shared code eliminates duplication, you also lower the effort and cost per feature, and you have more consistent code because they're shared, right? The data flow will always be the same across the different platforms. And there's also a nice feature about this is that your shared Kotlin code is compiled into native binaries. So it's compiled into something that the iOS platform understands. And so you can access those platform capabilities without additional overhead, which is really, really cool. So we've seen that most of the audience hasn't really played around with KMP. So I'm going to show you a really quick way to get started with it. I'm sort of going to deviate a little bit from my talk. So I'm sorry if anybody was super excited about the Swift interop. We're going to get there, but we're also going to have a look at some other stuff. So I want to share this tab, and this is basically just, I don't know if you can see the URL there. It's kmp.jetbrains.com. And this is our Kotlin Multiplatform wizard. So here I can decide I want to share code amongst all these platforms. I want to, for example, I have an Android platform. I want to share with iOS, and I want to share a desktop app as well. So I'm creating 3 different apps that are going to share code amongst each other. So with iOS, I can decide to share the UI. So I'm going to use Compose Multiplatform, or I can use just Swift UI, and I won't share the UI at all. So it's up to me what I do there. And there's also web, which will be WASM. So WASM is just a new way of doing web stuff. And it's really up and coming and really cool. And you should definitely go and check it out. And you download the file, and you can start opening it in your Android Studio. So I'm just quickly going to share Android Studio. Okay. So what I've got here is I've got my, it's basically just a little Kotlin project. And this is what you would download if you actually had gone ahead and, you know, gone through that process. So you have in here, we've got I just have an iOS and an Android app, but my Android app is basically over here under Android main. You can see the activities there if you're familiar with Android. And then there's a common main directory where all your common business logic is going to be. And you also have iOS main where all your iOS stuff is going to be. Now, why is there these different directories and what is their function? So I also want to just point out there's an iOS app directory that you can actually open in Xcode. So if you open it up in Xcode, you can see it's a proper Xcode Swift application that we're going to build. And it's just going to take a while to open, but that's there. Okay. See, I know probably most of us don't really understand Swift, but this is a proper iOS app that runs Swift UI, and here's the content that goes in there. Okay, so what I wanted to show you is that we have this little piece of logic in here called platform. So this is just normal, this interface is just normal Kotlin, all right? We have an interface called platform that has a variable name inside of it. And what we're going to do is we're going to try and get the system name and system version of the operating system of the device that we're running on. Why do we want to do this? Because I want to illustrate to you that I can do platform-specific stuff on each platform. So the way that this UI, which you can actually see here on the right, it just says running on Android 34. This is obviously an Android emulator, and it's one of the latest SDKs. It's 34. Okay, so we're just basically going to go ahead and return in this little function, just return platform.name, and this goes in a compose, a Jetpack. Well, it's actually a compose multi-platform little application that's just going to call this greeting class to get the platform name, and then write a little text element that says running on, and then the platform name. Okay, so I know this code is like not the best, but this is completely on the fly, so you're gonna have to excuse me. Okay, so how do I get Android 34 on this screen? Why can I get, I might just flash a YouTube video that I'm working on. Why can I get on this emulator? This is an iPhone 16 emulator that's running iOS 18.1 on. Why can I get iOS 18.1 on it? How it's exactly the same program. How can I get this running? So what I need to do is, so we've seen that we have this platform class, and the magic here is in this keyword over here that says expect. So you'll notice here we have a function called getPlatform that returns this interface. So it's going to return something of type platform, and we're saying that we expect some behavior, but that behavior is not going to be implemented in common main, which is like how we get common code into our apps. We're going to go over here for Android. We're going to say, okay, we're going to have a little instance of Android platform that has a name Android, and then, like, I don't know if you've ever played around with your build.gradle, but you can actually go ahead and get the SDK version for your Android device by saying build.version.sdk in it, okay? For iOS, we can do something completely similar. We instantiate something called iOS platform, and it gets the name from the UI kit. So this is actual iOS code that we're calling from iOS main. There's just different bindings associated with the iOS code. So there's things for Metal, there's things for platform, for foundation, there's all kinds of different things. And we're just getting the UI device, current device, system name, and system version. And that's how I can get the iOS device information on there. I hope that's kind of clear. I know it's a lot to take in, but the short takeaway is that with KMP, you can share code, sort of share like things that are very common to the application. Maybe it's like an email validation, something very small. It could be all of your business logic. It could be like a login thing, or it could be some other validation thing. You can share all that, or you can share the UI. You can share your login screen, or you could go ahead and there's also a way for you to access platform stuff. Here we saw we could get the system information, but you could also get things like your system's location, and that's stuff that you have to do with a platform-specific way. But you can also get things like your file system. You could get all these different things. You know, you could interact with your network by getting maybe like the Wi-Fi name or things like that. And there's so many multi-platform libraries that you can actually go ahead and use. So there's ways for you to do multi-platform without really understanding iOS all that much, or understanding Android if you're an iOS developer all that much. You will have to understand something, but it will be a little bit less. So, okay. So I have 15 minutes to tell you about Kotlin Swift Interop. So if you're not very certain about KMP and all the things that are associated with KMP, then this is a good space for you to maybe just take a small nap, or to try and understand what you will have to do in order to get your Swift application to understand how to talk to your Kotlin shared code. Okay, so I will completely understand if you want to take that nap, but maybe you learn something. I hope that you do. So today's talk is a deep dive into improving your Kotlin Swift interop, both now and in the future. And it is going to be a more advanced talk. I gave this talk at Kotlin Conf earlier this year. So it is an advanced talk. It is a detailed talk. But the first key takeaway really has to do with, so if you're interested in watching this talk and seeing the whole thing, it's on the Kotlin Conf website. So the first takeaway is really got to do with the current state of Kotlin Interop. So there's features in Kotlin that you can use from Swift with confidence, and there's Kotlin features that you rather should avoid. And it's just to be nice to your iOS developers, because when they try and use that shared Kotlin code, it's maybe going to be difficult for them to use. And you're probably wondering why, but I'll get to that in a second. So my second key takeaway is about the interop techniques you can already use. So we're going to be looking, hopefully, at 8 little nuggets of tricks that you can start using today on how you can make your Swift interop a bit better. And then we're also working on a really cool project called Swift Export, where we're going to alleviate some of the Kotlin Swift interop challenges in the future. And we're going to be looking at that project and how, what problems does it aim to solve. And we also had a look at the design process of how this language team goes ahead and tries to tackle the differences between Kotlin and Swift, and how they work as languages and how we can sort of integrate them and you have that interop, understand, the languages understand each other properly. So let's get started. It's a packed session, and I have 14 minutes to do it in. Okay. All right. So Kotlin Swift interop has to do with calling Kotlin declarations from Swift. So it doesn't affect the internals of a declaration. So say you have a function and you want to call that function from Swift, but you are wondering about the internals. Can I still use a variable that is, maybe using a coroutine or something like that? Not a variable that is using a coroutine, but you can use coroutines inside that function or something like that. But what I'm trying to talk about today is calling that function. Creating a class or calling those declarations. That is actually what is affecting the way that our Swift developers are going to write their code. So what exactly is the problem? So in 2018, when Kotlin Multiplatform came around, we decided to be interoperable, for KMP to be interoperable with Objective-C, not Swift. So why did we make such a oldies decision, right? So we decided we wanted to be able to use KMP in all iOS projects. There were still a lot of Objective-C projects at that time, and because Swift was still on the road to maturity and adoption at that stage. So that means that Kotlin is actually not directly interoperable with Swift, but rather indirectly via the Objective-C bridge. So Objective-C and Swift are very much related languages. They're both used on the iOS devices, but so it's easier to get Kotlin to talk to Objective-C than for Kotlin to talk to Swift. And when Kotlin does talk to Swift, it's via this Objective-C bridge. So this has a couple of things for Swift developers. Some Kotlin features are going to work exactly as expected. Some work with small workaround, some better with a community solution, some don't work so great right now, and some don't work at all. So let's have a look at my first section about Kotlin Swift Interop. And I'm going to start with a spoiler. The good news is what works far outweighs what doesn't work or isn't supported. So let's have a look at what works as expected. And I actually want you to more focus on colors and amounts rather than what is actually here. Trying to read the text in this light is maybe a little bit extra. Okay, so here we have what works as expected, things like classes, functions, properties, those kinds of things, okay? What works with a small workaround, you can see there's more here, more green. Things like top-level functions and top-level properties, exceptions, and so on. What works better with the community solution, so a little bit less here, just suspend functions or your coroutines and floats. What doesn't work optimally right now and should be used with care, things like data classes, generic classes, and functions, so generic functions. And what doesn't work, a small minority, because a small minority, things like calling functions with value class parameters, var args, and inline functions, okay? So what I really want to tell you about what we just saw, because that was, went past pretty fast, right? Is there are the more common features like calling, instantiating a class, a simple class, calling its constructor. That tends to be better supported than things like reified functions or something like that, something strange, okay? Then choosing a simpler way of doing things or choosing the simpler feature is usually the best approach with the current state of Kotlin Swift Interop. So to reiterate, what works far outweighs what doesn't work, okay? So if you just look at the colors, I see a lot of green, I see a little bit of red, but I think it's just the optical illusion. Okay, so if you're very curious about like how the different features work and how to get, how to call a function, how to call a data class, how to instantiate a data class from Swift and things like that, you can have a look at this website. It's Kotlin/Interopedia. It's a really great resource. It's called, so Interopedia is short for Interoperability Encyclopedia, which is 2 big words. And it just explains how to use Kotlin features from Swift. So it goes through all the features and has like code samples on showing you like how to call a particular function, all the caveats of calling the function. Maybe there's some things that you have to be aware of, things like that. So there's lots of code samples. It gives workarounds and community solutions. And there's also like a little playground app that you can use to call the different functions or call the little code samples, and you can go play with it and you can see how you can improve the interoperability yourself. Has anybody heard of the JetBrains code editor called Fleet? Has anybody heard of JetBrains? Ah, okay, that's a little bit better. So you can use Kotlin Multiplatform from IntelliJ, the popular Java Kotlin IDE, but Fleet is a new code editor that you can use. It is a polyglot code editor. It means that it works with different languages both at the same time. And we'll see here how we can do that. So here we have some Swift code. You can see at the top here it says .swift, and it is calling into the Kotlin shared code. Now, if I sort of command click into it, I get to the shared code. So it understands how the two are linked, and you can actually get into the shared Kotlin code. And we can also go back and get all the usages of a Kotlin function. We can refactor, rename, debug, all those things just from Fleet for Kotlin Multiplatform. At the moment, it is in EAP. It is meaning that it is still in development, but you can use it for free if you want to help us test. Okay. So I wonder if we shouldn't stop here. And if you have any questions about Kotlin Multiplatform, now is the time for you to ask me. I have 7 minutes. Let's use that time to talk. It can be super basic. It can be anything you want about Kotlin or Kotlin Multiplatform. Yes.
So I'm just trying to understand everything. And I guess my main kind of like question is, Swift is now available for Linux. As far as I understand it.
Okay. Yeah. So Swift can be used on, like, it's a server-side language, and it's also for iOS, Mac OS, tvOS, and so on. I didn't know that it's available for Linux, but that's also cool. Yeah.
So in terms of all these interpretations from Swift to whatever else.
It's an alternative. I don't think they've gotten quite as far as Kotlin Multiplatform, sharing like things between Android, iOS, all the different most of the different desktops, and also web and web, which is JS and WASM. So I don't think they have gotten quite as far. But there is, for example, a really cool server-side Swift conference that you can go to, but I didn't know that they actually were running on Linux. That's really cool. So I think, you know, whether they run on Linux or not, they're going to have to bridge the Android problem at some point in time if they want to contend with Kotlin Multiplatform. And so they're going to have to do what we do, just in the opposite direction. So I don't know.
Just then to understand what you do. Basically, if I write some code on Swift and I develop everything in Swift, you basically then say, okay, you can take whatever it is I've done in Swift and be able to put it on a different record.
It's the other way around. So I can have Kotlin code that is that I developed on, say I have an Android application, and I have some business logic that I sort of split out from my Android application separately. Then I can actually run that Kotlin code on my Swift application or on my desktop application. It's the other way around. Yes.
Thank you guys, Pamela, for the presentation. That's pretty beautiful. So what you actually have is the reason why I've been learning actually Kotlin was because most of the actions we before the company was through the activator, and one of the touch points is the fact that we actually reach some barriers to actually afterwards moving away from the activator, but actually to the native part of it. Does Kotlin have some of the downsides in that side? So like, let's say we were writing a program in Kotlin, and it of course interprets into Android and iOS. And then afterwards, we don't want to actually use Kotlin anymore. We just want to actually follow the app on its own. Would you mean barriers? Yes.
But would that be, so you would write the app on, like in Swift UI with Swift?
Yes.
So usually what we say to people when they sort of ask a question like that is, you know, if you do build an app with Kotlin Multiplatform and it's a Swift app, it's a Swift and iOS app, maybe Swift UI, and it is an Android app written in Kotlin, and you have that shared layer between Kotlin, between the two with Kotlin Multiplatform. Then, if you do decide to write everything in Swift or in Swift UI, you have a really cool Android app that you just wrote. It can run on desktop. So I would say like a gradual approach for you to start with is usually the best idea. You know, share something small. I know when I was still developing, like I was working at some fintech companies in, you know, in various parts of South Africa, and like analytics was always a big problem. Like, how do you get analytics to look the same on both platforms? You make a typo here, you get a typo there. You know, you don't get that typo there. So it's always like difficult to sync those two things. But I don't know if that helps.
Yeah, that helps actually a lot, actually. Just the gradual approach.
The gradual approach is really good for you. Yeah.
Yeah, actually 2 questions. What's the current estimation percentage about DMP sharing or writing common code across all platforms? And second would be, how we have an app developed in Kotlin. What is the upgrade path to DMP?
So if you already have an app in Kotlin, it depends on whether you want to, what you want to share in your iOS app. We actually have a tutorial that I'll share with you about taking your Android app and making it an iOS app. It's a really cool tutorial. But basically, is it a Jetpack Compose app or is it an XML-based app? Okay, so that makes it a little bit harder. You can share business logic, but it's so much easier to convert a Jetpack Compose app to Compose Multiplatform. It's basically just changing the library name, the library dependencies. So it's actually really cool. Your first question, I didn't quite catch. I think I forgot.
The advantage of commonly shared code. If I go for DMP, compared to one on 5 platforms.
Oh no, I think it.
Commonly, that is not platform specific.
So usually we have a very interesting graph that talks about what is shared, but I don't know what the common percentage is. I can tell you a few companies that are using KMP. I can tell you a few companies that are using it for different layers and things, but I don't know about, I think it varies too wildly to give an estimate. So companies like Philips, the Dutch electronics company, use it. McDonald's, Forbes, the sort of big companies. Meetup used to use it until they let go of all their engineering stuff. But there's big companies that are using it. Of course, we've partnered now with Google, and they're using it in some of their products as well. So and then in terms of what is shared, your biggest share is usually your data layer. People are still coming on board with the UI layer, which is on the other side of the spectrum. But there are companies that are using it. Compose Multiplatform for iOS is only in beta at the moment. Soon it will be in stable. We are still working on a few bugs, but we basically just want to give the best experience. So Compose Multiplatform is still in beta, and mostly it is things like data layer and connecting to a web service, connecting to a database, things like that. And then you can even share view models and all those different things. So I think we're out of time. If you have any more questions, I'll be around today. Thank you so much. You've been an awesome audience. There are JetBrains stickers, and apparently at the reception there are also Kotlin stickers, JetBrains pins, Kotlin pins. Just have a great swag, everyone. Thank you.